We will bring it to the fire, as you can see. It does not burn, only gradually melts. Then we'll take the ashes and dip the sugar into it. We bring it to the fire again, and this time the sugar starts to burn. Even if you remove it from the candle, the fire does not disappear, and the sugar is covered with the crust and then completely explodes. That's how it was. But sometimes sugar can burn out without exploding. Why do you think it started burning at all? Fill the glass with refined sugar to the top. And then completely immerse in it warm water. After a while, some of the sugar dissolved in the water and some remain lying in the bottom. Now, add a little potassium permanganate to the liquid. As you can see, it stays on the surface without sinking to the sugar at the bottom, even if we start to stir it. In ordinary water, potassium permanganate immediately attends to the bottom and mixes with water. No matter how much we interfere, the result is the same. And after 20 minutes, the liquid turns brown at all. Although half with sugar does not change, let's try adding green dye to one glass and iodine to another. Stir and get the same result as with potassium permanganate. And now there will be a trick. Look carefully. Let's make a number and write it on a sugar cube. We throw it into the water and stir it. Now, hold our hand over the water and the number miraculously appears on the palm of your hand. And here's the secret. We just print a number with the sugar on our finger, and then we put it in the palm of a person. That's all. Let's take a balloon and the funnel. With this help, we will pour sugar inside. Let's take a bottle of soda and pull our balloon on the neck. Try not to spill the sugar. Now we start and watch how the foam and gas quickly fill the ball. Oops! It's not easy to keep it up. Let's try it with other sodas. After all, the most powerful thing came out with cola. But now, we see that balloons inflated with gas stand and on the bottles exactly. Put a wooden board on a baking sheet and pour little sugar on top. Now add dry potassium permanganate to it. We mix these substances with the wooden stick and then we begin to crush them, turning them into a homogeneous dust. A little more pressure. And a fire breaks out. What a powerful flame! In no case, do not repeat it at home. This is a very dangerous experiment. Let's take some food wrap and make 2 identical squares of it. Pour about 2.5 tablespoons of sugar on each Add a quarter spoonful of starch to one of the squares, mix, and begin to wrap in the bag. We will tie it with the thread several times for reliability. We do the same with the second film, but with the thread of a different color. Cut off the excess and put both bags in a bowl of water for 30 minutes. And then take them out. Now add iodine to the container with water and dissolve it. We will hang our bags over the solution and cover them with the lid. After 12 hours, changes are visible. Pour out the sugar for clarity. With pure sugar, almost nothing happened. But sugar mixed with starch acquired an ashen color. In a bowl, pour a few spoons of powdered sugar, and then add a little soda. Now we pour our sand on a baking tray and pour alcohol on it so that it gets soaked. Pour our mixture on top, level it, and ignite the alcohol. A chemical reaction immediately begins. The mixture begins to turn into a black mushroom-like appendicus, like monsters from TV series of One of Us. It looks creepy, but at the same time, fascinating. And that's what remains in the end. There's a charm in this figure. Let's take sulfuric acid and very carefully begin to impregnate refined sugar with it. Add a little bit and the sugar gradually begins to turn black. Continue until all the sugar turns black. Now we just watch. We see how the liquid begins to flow out of the sugar, and then it begins to deform and grow, faster and faster. Gas is already starting to be released, and the sugar itself seems to be boiling. Finally, the reaction is completed, turning the sugar into a soft, sticky black mass. It's time to conduct a larger experiment. Fill the glass jar with granulated sugar about halfway up, and now let's move on to the most dangerous part. Pour the sulfuric acid inside and start stirring everything as quickly as possible until the reaction begins. Now it only remains to observe from a safe distance. Again, the substance begins to gradually turn black, and then gas and smoke appear, after which a huge black something begins to crawl out. Somewhat resembles a slug from outer space, causes ambiguous emotions. As you can see, the mass has risen much higher than the volume occupied by sugar and acid. Let's take a closer look. Wow, this thing is hot. Break off a piece. As you can see, it crumbles easily in your hands. Let's repeat again. We put the ball. At first, it just floats. Then, the deformation begins. The bigger it is, the higher the ball rises. Until finally, it falls out of stream once again. Again, the same story. The stronger the deformation, the higher the ball soars. But in the end, it still falls. Look it up close. It gradually swells like a grain of popcorn during frying. And then, when the shape is too uneven, it simply falls under its weight. And now we have managed to repeat the same result at the first attempt while the ball is smoking. And in a matter of seconds, all traces of the ball are erased. In fact, everything can be made easier by piercing the ball with the screwdriver and placing it under the hairdryer. It starts to melt, then a huge amount of smoke, but without fire this time. Let's try again. We direct the hairdryer perpendicular to the screwdriver and the process goes faster. First it melts, then a bunch of smoke, and finally fire. And balls are much more dangerous than you thought. We pinch a match in a vise and point a construction hairdryer at it. It lights up and goes out just as quickly. And what if you pinch all the matches out of the box? Matches light up in a chain reaction in a second. Here are the slow motion shots. It can be seen that the fire sweeps through all the matches very quickly. Look again, a second flash, and they go out. Let's try to heat a whole box. We bring the hairdryer, nothing seems to happen. But then it starts to darken and then a flash of fire from inside. It's burned out all the matches. Let's open it and make sure that none of them survived. It's the lighter's turn. Let's bring a hairdryer to it and see what happens. Everything is calm and then there's a shot literally in a second. Look in slow motion. As soon as the plastic melted, the gas bursted out and threw the lighter away. It's the same result every time. Let's try to squeeze it in a vise. We heat the lighter. There's an explosion. Then another one. But in the end, the gas just evaporates from the lighter. On the second attempt, the same result when there is no gas. The plastic just melts. Unfortunately, it was not possible to cause a fire, but we don't give up. We simply increase the number of lighters, as many as 5 lighters in a vise. Turn on the hairdryer. We warm them up evenly. Here's one explosion after another, but again, no fire or even smoke. It seems that lighters are quite safe without a spark, except for a powerful clap from the release of gas. Take a roll of toilet paper. Let's see what our hairdryer will do with it. The video will have to be accelerated because the process was not fast. You can see that the paper is gradually changing color, but there's no fire yet. But we're not going to give up. Let's direct all the heat to one point. After 4 minutes, smoke appears, which means there will be a fire. Finally, the paper breaks out. It will burn for a long time. Look at how it will gradually decrease while it burns through layer by layer. We better put it out by removing the oxygen with the glass bulb. But the spectacle turned out to be very interesting and could not be taken away. Let's take a can of Coca-Cola and put a hairdryer next to it at full power. It will have to wait for some time. Even a construction hairdryer will not warm it up so quickly. After almost 6 minutes, the jar finally gives in, or rather, the liquid inside splashes out, tearing off the top part. Look at this fountain in slow motion. What a powerful splash! The foam soared almost to the ceiling, and now it's smoking. The cola is so hot. Look at what a perfect slice turned out. Okay, it's time to move on to a glass bottle. Install a hairdryer and watch. As you can see, during the heating process, the volume of the cola seems to increase. After 8.5 minutes, we finally get a result. A huge fountain of cola shoots out of the bottle, knocking out the cork. Look how beautiful it looks in slow motion. The foam hits the ceiling, scattered all over the studio. The fountain turned out really huge, and then it turned into a rain of cola.